Okay, in question number 3, we are required to sketch 111 and 100 planes for a face-centered cubic crystal structure and calculate the planar densities. So again, let us start with the 3D projection. We are dealing with face-centered cubic system. Always place the coordinates and show the which one is the which axis belongs to which. Now, for face-centered cubic crystal structure, we have 8 corner atoms. One at the back here, and the face atoms. So, one front, one back, one right, one left, one top and one bottom. Now, the planes that we are asked to draw, first one is the 111 plane. In order to find which points intersect, we take the reciprocals of these indices. These are known as Miller indices. The reciprocals are 111. So the 111 plane intersects all 3 axes at the index 1. So at the edge, at the corners of the unit cell. And if you draw it, it looks something like this. A triangle sitting inside the cube. This is our 111 plane. Now, I'm going to draw this separately. You can draw it on the same diagram, if you can draw it better than me. Again, we have the same system. 8 corner atoms. I'm not going to draw the face atoms. Well, let's show them anyway, for completeness. And 011 plane is asked. Take the reciprocals. This is going to be infinity, which means parallel to x axis 1, 1. So it's going to intersect y and z at the corners, but it's going to be parallel to x. So if you connect, it should be something like this. And if you draw these planes alone, so 111 plane is going to cut through the centers of the corner atoms and the face atom. Similarly for 011, it's going to cut the centers of the corner atoms and the face atom at the front and at the back. So let us draw the planes themselves now. The plane 111 is going to be an equilateral triangle, meaning all 3 edges will have the same length and all the atoms are going to be touching to each other. So don't be fooled by my drawing. All these atoms have the same size, have the same radius, and the atoms occupy this much area in this plane. As for the 011 plane, this edge has length, this short edge has length a, and this long edge has length a square root 2. So if you draw it like this, this has edge length a, this has a square root 2, and the atoms are going to be touching each other on the long edge. So draw it like this. they occupy this much area here. Okay, so what about the edge of this 1, 1, 1 plane? This edge. This edge is going to be a square root 2. Since this is an isosceles triangle and the edges lie on the face diagonals, all three edges have the same length and they are a square root 2. Now we are required to calculate the planar densities of both of these planes. So planar density, by definition, for a given plane is going to be area occupied by one atom times the number of atoms divided by the area of the plane. Okay, so each atom has area pi r squared. We know that from basic geometry. Now the issue is calculating the number of atoms lying inside the plane and the area of the plane. If you draw an equilateral triangle with side length x, then its height is going to be x square root 3 divided by 2, and this is going to be divided into equal parts. That's the geometric property. You can prove it by trigonometry as well. Then the area is going to be height times the base divided by 2, and that's going to give you x squared square root 3 divided by 4. In this case, our x is a square root 2 here. So for an FCC structure, a square root 2 is equal to 4r. So the a is going to be equal to a square root 2 squared square root 3 divided by 4 for the 1, 1, 1 plane, or you can simply write 4r squared square root 3 divided by 4. This is the area of the 1, 1, 1 plane, and area occupied by the atoms here. So pi r squared times, so we have three corners. This is 60 degrees and the whole atom is 360 degrees, so 60 over 360 we have 1 over 6, plus we have these center atoms here. They are lying on the middle of each edge, and half of them are inside this plane. So 3 atoms, half of them are inside. If you simplify this, you will get 2 pi r squared. So our planar density expression for 1, 1, 1 plane is going to be 2 pi r squared divided by 4r squared square root 3 divided by 4. If you simplify this expression, you will get 4 square root 3 r squared, and that's going to be pi divided by 2 times square root 3, and that's going to give you 0.9069. So if you calculate all the different family of planes, density of family of planes for FCC, you will see that this is the most dense plane, and these most densely packed planes have special names called slip planes. Okay, so that was 111 for 011. Area occupied by the atoms is going to be pi r squared times 4 corners, 90 degrees, 90 over 360, so 4 times 1 over 4, plus 2 centers here, times half of them are included inside the plane, divided by a times a square root 2. this edge times this edge is the whole plane. So we have 1, 2 pi r squared divided by a times a is going to be a squared square root 2. A squared is going to be 2 square root 2 r squared square root 2. Modify this expression again to get 8 square root 2 r squared. Simplify to get pi divided by 4 square root 2, and that will give you 0.5554 as the planar density.